crafting is pretty essential to Minecraft, so essential that it's even 50% of the name. Which is why I recently added crafting to the fully custom Minecraft server I'm crafting from scratch in Rust. This also means that I can now finally show you how crafting actually works. All you need is some paper, optionally with a template like this printed on, some colored pencils, scissors and some glue. Then you just need to draw a crafting table texture onto the paper like so, cut it out, fold it up like this, and then put some glue on the tabs while assembling it like that. Pretty simple, right? Well, thanks for watching. Wait, you wanted to know how crafting works in Minecraft? Well then, strap in. The first step to crafting is to detect when the player tries to craft something, which is a bit different between crafting tables and the crafting field in a player's inventory. When using the latter, crafting uses the slots numbered 0 to 4 of the player's inventory, with 0 being the output slot and 1 to 4 making up the 2x2 crafting grid. This means that we can just reuse our existing logic to handle the click container packet, which is also used for moving items around inventories. The same packet is also used when interacting with blocks that have an inventory, like chests. Moving items to a crafting table works on the same principle, just with a little twist that the slots of the crafting table don't actually exist. What I mean by that is that they are not stored anywhere permanently. Chests, for example, have a block entity associated with them which stores their inventory. Crafting tables don't have that. We obviously still have to keep track of the items in the crafting table, so where do we put them? First, I thought about just creating my own block entity for crafting tables, which shouldn't have been too complicated. But then two players would see each other crafting in the crafting table, which isn't really how things work in vanilla. Instead, I ended up just storing the crafting table slots in the player struct, which worked well enough. I still had to add more logic to my click container packet handling code than I would have liked, but oh well. Now that we know when the player interacted with the slots that are used for crafting, it's almost time to actually do something with this information. Before we can do that, however, we need to first look at crafting recipes. Crafting recipes are there to tell us what can even be crafted and how. Luckily, we don't need to add them all by hand, as the official Minecraft server can already give those to us. We just need to ask it nicely by running it with some command line arguments like so. This generates this directory structure in which we can find a JSON file for every crafting recipe. These look a bit different depending on the kind of crafting recipe they represent. I'm not going into all the specifics in this video. Instead, I would recommend you to just check out the wiki article linked in the video description. There you will always find the most up-to-date information. For now, the two most important types are shaped and shapeless crafting recipes. Shapeless recipes just define a list of ingredients that produce a certain item as an output when all the ingredients are present. Shaped recipes, on the other hand, come with a pattern and a key. The key maps a single character to a list of possible items, while the pattern then tells us how those ingredients need to be arranged to get us the desired output. The ingredients for both kinds of recipes can hold either a single item ID, a list of item IDs, or also a whole tag representing many more items. This is used for recipes in which multiple ingredients can be used interchangeably while still resulting in the same output. For example, when trying to craft a crafting table, you could use 4 different kinds of wooden planks all at once. Representing this in a fixed way would result in massive amounts of functionally duplicate crafting recipes. Now in theory, I could just read in this directory of JSON files at runtime, but that would mean that running my server without those files would be impossible, which would be kind of annoying. So instead, I parse them and generate Rust code from them once. This is done by a little utility that I wrote that already does the same for other things from the generated JSON files like items and blocks. The result is a single file with almost 20,000 lines of Rust code. But hey, that's a lot faster to search through than a bunch of JSON on disk. Now that we have all those recipes at our fingertips, it's time to actually make use of them. Now that we know what the player put into the crafting field and which crafting recipes exist, it should be trivial to figure out if what the player is doing is a valid recipe, right? Well, for shapeless recipes, it definitely is pretty simple. Just check if all the required items are in the crafting field and that there are no leftovers. In the end, there should only be at most one valid recipe. Shaped recipes, on the other hand, are a bit more difficult. The problem there is that the pattern of a recipe is often smaller than the crafting field. This means that there are many possible positions for the items we need to check. I have found a solution that is relatively simple, but probably not the best one out there. I just look at the pattern's shape, and from there I calculate which places the ingredients could be in. I do this for every possible place the recipe could be in. For example, when you're trying to craft a crafting table in a crafting table, there are 4 possible places you could put the items in. This would result in 4 entries in my possible shapes vector. For bonus points, I also store the horizontally flipped shape in this vector as well, for patterns where it makes sense. Then I just need to go through that vector of possible shapes to check if the reality matches with any possibility. There are likely faster methods of implementing this. I could also add some caching so that I have to recompute less stuff for each lookup. Maybe I could also get rid of the possible shapes vector and just check things right away. Anyways, perfect is the enemy of good and stuff, so let's quickly move on to the next step. Now we have all the logic in place that tells us if the player just put all the items in the right place to craft some specific item. All that's left now is to actually do the crafting. The first thing we need to do is to send the player a set container slot packet to set the item that gets displayed in a result slot. Now we have to wait until the player actually takes that item out. Then we either need to put the item into the player's cursor, or if the player already has that item in the cursor, we need to add another one to that stack. We also need to decrement all the items in the crafting field by 1. Sending a new set container slot packet to reset the output slot to have the item again is also necessary, but only if the items that are left can craft the result again. Otherwise, the player could only craft a single item and then the result slot would remain empty. Well, and that's already everything we need to do to get basic crafting going. There are of course still some special cases I haven't implemented yet, like combining tools to repair them. But for now there are more important features to add. Instead, let's look at a different form of crafting, smelting. It may not immediately feel like you're crafting stuff in your furnace, but all the basic elements are still there. A specific input item gets you some desired output back. Smelting recipes are part of the recipe JSON files we already talked about, so there's nothing new here to implement. There are actually 3 different kinds of recipes for smelting, blasting and smoking. Just as with crafting recipes, each smelting recipe defines a list of possible input items that result in a specific output item. The cooking time also gets specified, although that should always be the same. The earned experience points are also in there, but I don't currently do anything with that. In my video about block entities, I already talked about how smelting works, so I won't go into much detail here anymore. I just replaced the static input and output items with my recipe system. I also added the fuel values for all items by hand so that any fuel can be used. This information doesn't seem to be contained in the generated JSON files, but adding those manually also didn't take too long. Now you can smelt any item just as in vanilla, using any kind of fuel you desire. Things still feel a bit janky, but for now it's good enough and I had to get this video out at some point. Now the basics of survival Minecraft are implemented in my server, which is quite exciting. You can mine for blocks, smelt the valuables you found underground and then craft those into new items. Now I really need to deal with the lack of food. You should get subscribed if you don't want to stay hungry. See ya then.